Welcome to Screencast 4.5, Graphing Other Trig Functions. So hopefully you recall that tangent is equal to sine over cosine. So if you know the unit circle, you can get your sine and cosine values from that. There's going to be 4 points that we're going to be interested in. So these will be the quadrantal angles. So I'm going to go ahead and label those 4. So here, don't forget our xy coordinates correspond to cosine and sine. Alright, so cosine is x, sine is y. So at our first 0-degree angle, we're going to have an xy value of 1, 0. At 90 degrees, or pi over 2, we'll have a value that is 0, 1. At pi, we're going to have negative 1, 0, because we're negative 1 on our x. And then at 3 pi over 2, we have 0, negative 1. So at each place, the first number, our x coordinate is our cosine, our y is our sine. So if tangent is sine over cosine, we have to be aware of when cosine is equal to 0, because that would mean we're going to be dividing by 0. So tangent is undefined at all points where cosine is 0, because this is where we're dividing by cosine, so we're going to have vertical asymptotes. So that will look like this, these red dashed lines. So notice that cosine is 0 at pi over 2 and 3 pi over 2. So 2 times in every 2 pi cycle. So we have 1 time and we have 2 times in every 2 pi. Alright, so in general, just like the sine and cosine function, we can have a general form of how to write tangent. So keep in mind this A is the amplitude. That's what this A is. D is the vertical shift. C deals with our phase shift, and B deals with the period. But overall, to figure out both, to figure out where we start graphing our phase shift and like how big the period is, we're going to use almost the exact same thing that we did for cosine and sine. We're going to be solving a system of inequalities. So before, you may not have realized how awesome using inequalities is. But here, especially for the tangent function, this will automatically solve for our asymptotes, where we have these vertical asymptotes, as well as how big the period is. So let's go ahead. We're going to try example 1, locate the vertical asymptotes, and then sketch the graph of y equals tangent 3x. So I'll have negative pi over 2 less than equal to, well, my bx plus c is going to be just the 3x less than equal to pi over 2. Notice that this is different than our previous inequalities. So with sine and cosine, our periods was 2 pi, but here, literally the length of our period is the distance between 2 vertical asymptotes. So this distance right here is a single pi. Normally we like talking about from negative pi to pi, because that's the one that goes around the origin. So the length of the period is just going to be pi, because I have pi over 2 to the left of the origin, pi over 2 to the right. I add that, and that will be 2 pi over 2, which is pi. Because keep in mind, distance is never negative, so I just want to know what's the total distance between the 2 vertical asymptotes. Alright, let's get this guy by himself, so I have to divide by 3. So in a little aside, pi over 2 divide by 3. So when you divide by a fraction, same as multiplying by the reciprocal. So we have pi over 6. So both of our values are now going to go to pi over 6. Negative pi over 6 less than equal to x, positive pi over 6. So this means that we're going to start graphing at negative pi over 6, and that's where we're going to have a vertical asymptote. And we're going to finish graphing at pi over 6, and that's where we'll have our other vertical asymptote. So the distance between these is going to be, let's see, distance between them. So we're going from negative pi over 6 to positive pi over 6. And so keep in mind, distance is never negative. I'm just going to be adding these together for the total distance. It doesn't matter that this one was originally negative, because this is the distance from 0. It is pi over 6 from 0. The positive pi over 6 is also distance of pi over 6 from 0. So we add it, and we see the total period is going to be pi over 3. So the total is pi over 3. Let's keep going. So our period is going to be pi over 3. I already said our asymptotes are when x is going to be plus or minus pi over 6. So we're ready to graph. So our issue with the graphing right now is, like, how do we even do this on the graph? So first, let's try to label our axes with numbers. That will actually be super helpful. So I know I'm going to have a vertical asymptote at negative pi over 6. I'll be here. And I'll also have a vertical asymptote at positive pi over 6. I know this is 0. I know, let's see, this will be 1. Here's negative 1. So halfway between 0 and pi over 6, well, halfway between 0 and pi over 6 is just going to be half of pi over 6. So that's going to be pi over 12. Another way to think of that is, well, if this is pi over 12, this one has to equal 2 pi over 12, which it does. 2 pi over 12 is the same thing as pi over 6. All right, and then let's label this one. So this will be negative pi over 12. Cool, let's make sure to draw our vertical asymptotes. So vertical asymptotes, vertical asymptotes. Okay, how are we going to plot this guy? This looks like a pain in the butt. So first, okay, let's try 0. Let's plot tangent of 0 degrees. So tangent of 3 times x. So here I have 3 times 0. That's just going to be 0. So tangent of 0, think back to our unit circle. Right here. This point has a coordinate of 1, 0. Cosine is 1, sine is 0. Because remember, x, y. Oh my god, that's embarrassing. Okay, cosine, sine. So let's see, tangent is sine over cosine. So it's going to be sine 0 over cosine 1, 0. So tangent of 0 degrees is always 0. Cool. The only time when you're plotting where this middle part won't be 0 is when you have a vertical shift. Luckily we don't. Cool. Let's keep going. So just like sine and cosine had 5 points to plot, well, actually unlike, tangent only has 3 points. So you want to do the vertical asymptotes. So draw your vertical asymptotes and then do the middle portion, which you know tangent of 0 is 0. And then you're going to do the halfway between middle and each vertical asymptote. Alright, so let's pick the next one, which is tangent of, let's do pi over 12. So this 3 comes from the fact that we have a 3 in our function. 3 pi over 12. All right, let's simplify that. 3 pi over 12 is pi over 4. Pi over 4, let's just tangent of 45 degrees. If you remember a 45, 45, 90 triangle, our bases are the same. Tangent and cosine are going to be the same. 45, 45, 90, it's an isosceles. Side lengths are the same. Opposite angles are the same. So tangent of this is pi square root of 2 over 2 divided by square root of 2 over 2. Which simplifies to 1. Simplifies to 1. So here's positive 1. Next one. Let's plot the halfway. Okay, so we did the vertical asymptotes. We plotted the one that's in the middle, so that's our 0. And then we're doing middle to each vertical asymptote. So I did the middle here, and that's going to be a 1. And then you may know that this is going to be a negative 1, but let's prove it. Let's do this. So tangent of 3 times negative pi over 12. That's just going to be tangent of negative pi over 4. So it's negative 45 degrees. So on your unit circle, it's going to be right here. If you think about it, we'll have a negative y, and x is positive. So we'll have a negative square root of 2 over 2 over a positive square root of 2 over 2. Simplifies to negative 1. Awesome. So we're at negative 1. So now we're just going to connect the lines, and vertical tangent means we can't touch the asymptotes. That's what your basic tangent function will look like. So I want you to try the next one. Locate the vertical asymptotes and sketch the graph of y equals tangent of 1/3 of x. So I'll give you about 3 seconds, pause the video, try out the problem, and then I'll show you the answer. So I went through, did the inequality. In order to get x by itself, multiply by 3 everywhere. I see my vertical asymptotes are negative 3 pi over 2 and positive 3 pi over 2. So that's why I put x is equal to plus or minus 3 pi over 2. So then I added them together to equal the total period of 3 pi. Another way to do this as well, it's the distance between these two vertical asymptotes. That is what the period is. So this is a length of 3 pi over 2, and this is a length of 3 pi over 2, which is why I added them. Another way to do this is if you look up here, period for tangent is pi over absolute value of b. So that would be pi over, well, absolute value of b is 1/3. So pi divided by 1/3 is the same as multiplying by the reciprocal. So pi times 3 over 1 is 3 pi. Cool. All right, I want you to try the next one. Example 2, graphing reflections and translations. I'll go like this. If you need to see the answers, go ahead and pause. Awesome. So example 2, locate the vertical asymptotes and sketch the graph of y equals negative tan of x over 4. I just want to point out something. Look, this is a negative, so think what it does to the graph. Try this one out, and then I'll show you the answer. So first we're going to find the period. So right here, I just do inequalities. I see that my two vertical asymptotes are negative 2 pi, positive 2 pi. And then the total distance between these two consecutive asymptotes is 4 pi. 1, 2, 3, 4 pi's. Because we are 2 pi from 0 on the left, 2 pi from 0 on the right, for a total of 4 pi, total distance. So I drew my asymptotes. Step 1, draw your vertical asymptotes, did that. I labeled my graph, and then I find my 0 in the middle of the two asymptotes, and then I do my halfway points on each side. So I did my 0 in the middle. So negative tangent of 0 over 4, well, that's just negative tangent of 0, because 0 divided by 4 is still 0. And then tangent 0, 0, so negative 0 is still 0, whatever. Next we have tangent, negative tangent of pi over 4. Well, you know pi over 4 is square root of 2 over 2 divided by square root of 2 over 2. So that's just going to be a negative times 1, so that's just negative 1. So, and then the last one, negative tangent of negative pi divided by 4, well, that's just going to be negative times, well, I know that negative pi over 4 is negative 1, so negative times negative is a positive. That is secretly what this negative sign here does. It flips everything on the x-axis. So we used to have our tangent go like this, but it was flipped down, flipped on the other side. Because all these used to be positive y's, now they're all negative because that stupid negative sign in the front. Same way over here, everything used to be negative. Well, when you multiply that by a negative, it makes them all positive. That's all it does. It just flips it on the other side. All right, last one with tangent. I want you to try B. Give you about 5 more seconds, and I'll show you the answer. All right, so here's the solution. Notice that we have a negative sign, so that flipped it. So that's why it looks a little different than a regular tangent. Also, we have this plus pi over 2. So this ended up being my phase shift because I subtracted pi over 2 from everything. So my whole graph is shifted over to the left by pi over 2. Notice here's my vertical asymptote, negative pi and 0. So I drew my asymptotes first. It's the first step. Draw your vertical asymptotes. And then I found my 0, which is in the exact center of my two vertical asymptotes. I made sure I don't have a vertical shift, so I don't have to move it up or down at all. It's right on the 0 line. And then I have I find my halfway points. So I could put in negative, tangent of negative pi over 4 plus pi over 2. So this gives me negative tangent of pi over 4. You already know pi over 4 is just 1, so it's negative 1. Boom, negative 1. And then the other one is going to be our positive 1. So then we don't have any amplitude change. So it'll be 1, 0, negative 1, and then you just connect the lines. So that's going to be your main point. It'll be 0, positive 1, negative 1. Always check if you have an amplitude change, your A value in front. Make sure you check for the negative. That will flip everything, and then you could check for the phase shift. as well as this guy would make us have a period change. Alright, let's keep going. So cotangent, I will cover in the next video.